Hey, it's Mr. Kingsbury, and today I want to start the first of several videos about different kinds of factoring. Now, the most basic kind of factoring is what we call GCF factoring, or greatest common factor factoring. So I got my notes all set up here. It's again for Algebra 2. Now our unit is about factoring, and today we're talking about the GCF. I am Mr. Kingsbury. Don't forget to put your period and the date, and our essential question is, how do I factor the greatest common factor out of an algebraic expression? It's not as hard as you think, but it does require a little knowledge of math facts and a little understanding of what a few things mean. So for starters, let's begin with the word common. Common means that it has to be a factor of all the terms. So, for example, if I have 4x plus 10, 2 is a factor of that, right? 2 is a common factor because 4 is divisible by 2 and 10 is divisible by 2. Don't worry about the variables. We'll handle those differently. That's a good example there. If I had 4x plus 7, there are no common factors. Okay, technically there's one, and it's 1, the number 1, but that's not helpful. Factoring out a 1 changes nothing. So we need to understand that whatever we're factoring out must be part of every single term. So once we can wrap our head around that, then it's really not a big deal. So I wanted to make sure we establish that. As far as the numbers go, we're just going to be looking for a number that divides both of them. In fact, we're going to be looking for the biggest number. That's why this is called the greatest common factor, which you can't see me pointing to because it's off camera. It's the greatest common factor. So it's not just common factors, but the biggest one. And then as far as the variables go, all you really have to do is look at the exponent. And whatever the smallest exponent is, that is the greatest common factor. Okay, what I mean is, if I have, for example, let's say I have x to the third plus x squared plus x. Well, this has 3 x's. This is x times x times x. This has 2 x's, x and x, and this just has 1. Now, if what I'm factoring out must be common, it must be in all 3 terms. So I certainly have 1x in all 3 terms, but I don't have a second x in all 3 of them. I have it in 2 of them, but not in the third. And I certainly don't have a third x in all 3. I have a third x in just 1 of the terms. So you can only factor out what's there. The example I like to use is cookies. Growing up, my brother, my sister, and I would all be allowed to get the same number of cookies, and we each had our own cookie jar. By the way, I'm completely making this all up, but it's a really good metaphor, so just go with it. So we each had our own cookie jar, and they all had different numbers of cookies, and my mom said we could all have the same number. So I could pull, like if I pulled 2 out, then my brother and my sister could also have 2 cookies, as long as there was 2 cookies in the cookie jar. There was one night where I pulled out 2 cookies, and my brother only had 1 cookie, and my sister had like 5. She was very ticked because we could only have 1 because that's all my brother had. You can't factor out more than what's there. So let me see if I can give you a couple of examples. And I'm going to show you how to do it in a way that I think is helpful, and writing it is helpful. Mathematicians have a tendency to streamline the process. So off to the side, I'll show you what most teachers would have you write. I'm also going to show you what I want you to write. So let's just do an example here. Well, let's keep it simple to begin with. Let's say that we have, let's do 10x cubed plus 15x squared. So the first thing that I'm going to look at is the numbers. And I know that 5 divides 10 and 15, so I'm going to try that. I'm going to factor out a 5. Okay, so this is how we write it. When you're factoring stuff out, you write what you're factoring out outside of the parentheses, and then whatever's left after you factored those things out goes inside the parentheses. So I'm going to write a 5 here. Then I'm going to look at the x's. This is x cubed. This is x squared. The smaller exponent is 2, so I'm going to factor out an x squared. Now, most teachers, they would want you just to write this, and then they would want you to write 5x squared, and then they would want you to write 2x plus 3. And how did I get this? Well, basically, I divided out here. And when I start talking about that, I noticed that my students' eyes kind of glazed over. That makes me think of donuts. Anyway, and I was like, okay, maybe it would be helpful if they understood where this came from. So that's why I put this here. When you factor out, you're actually dividing something that's common out of both terms. We're dividing both terms by 5x squared. So I want you to actually write that out. Okay, and let me walk you through where this comes from. So once you figure out what you're going to factor out, that part goes outside the parentheses, and then what's left goes inside the parentheses. 10 divided by 5 is 2. And x cubed divided by x squared is just x. Then I'll bring down the plus. 15 divided by 5 is 3. And look, x squared divided by x squared, that's I have 2 x's. I'm getting rid of 2 x's. So there are no x's left, which means I don't need to put any x. So I have that. That's factoring out. And if you break it into pieces, you'll be able to be much more successful at it than if you try and do too much all at once. That's another thing that I see students struggle with, is they try and do a whole bunch of stuff at once instead of taking it bit by bit. Let's do another example. Let's make it more complex. All right, I'll add another term on there. So, and a negative. So let's say we have 12x cubed. I'll go ahead and do, actually, let's do minus 16x squared and then plus 8x. So let's figure out what we're going to factor out first. I've got 12, 16, and 8. Now this is where knowing your math facts comes in handy. Yeah, they're all even, so we could factor out a 2. Don't write this down yet. I'll let you know when to write it down. We could factor out a 2, and if I look at the x's, I've got x cubed, x squared, and just x. The smallest of those exponents, or if you will, the fewest x's is just x. So let's try factoring out 2x. Here's what happens. 12 divided by 2 is 6. X cubed divided by x is x squared. Minus 16 divided by 2 is 8. X squared divided by x is x. Plus 8 divided by 2 is 4. And then the x's, they pretty much cancel each other out. That's not the right word. They get factored out. Here's the problem. Well, my x's are good. I have no more x's here, so I can't factor any more out. Look at 6, 8, and 4 all have a number in common. They still have a 2 in common. So 2 was not the biggest number that I could factor out here. There's got to be a number bigger that goes into them. I'm going to use the smallest number as my basis. The smaller the number, the fewer the factors. So we tried 2. 2 was too small. It worked, but I still had 6, 8, and 4, which are all divisible by 2. So that means it wasn't the greatest common factor. It was just a common factor. So let's try something bigger. What else goes into 8? 4 and 8. So I guess 8 is the biggest. We could try that. 8 divides 8. 8 divides 16. 8 does not divide into 12. So that's out. What about 4? 4 goes into 8. 4 goes into 16. 4 goes into 12. So let's try 4 instead. And I just ran out of lead, which is not good because you can't write without lead. So let's put 4, 4, 4. We'll put a 4 here, and let's see what happens. 12 divided by 4 is 3. 16 divided by 4 is 4. And 8 divided by 4 is 2. Now look at these numbers. 3, 4, and 2. They do not have any common factors bigger than 1. Yeah, 2 divides 2 and 4, but it doesn't divide 3. And 3 is straight up prime, as is 2. So there's nothing else to factor out there. All right? These are the things you got to be careful of. And I would much rather you factor out a common factor and then keep going. That's fine. If you do that, just keep multiplying this here. I mean, essentially, I tried 2, and I realized that all the stuff in the parentheses was still divisible by 2. What's 2 times 2? 4. And that's what I ended up factoring out there. Let me do one more, and then I think we'll be done with this video. So I I feel like there was something else that I was supposed to show you, but I don't know. Anyway, let's do this. How about 7x to the 5th plus 21x to the 4th minus 14x cubed. Let's figure out what we can factor out. So let's look at the number first. I got 7, 21, and 14. These are all multiples of 7. And there's only two things that divide 7, 1 and 7. So let's try factoring out a 7. And then I'm looking at my exponents. I got 5, 4, and 3. So this will be what I can factor out, x to the 3rd. So I'm going to factor out 7x to the 3rd, and the question is what's left. So 7 divided by 7 is 1. X to the 5th divided by x cubed is x squared. 21 divided by 7 is 3, so I got plus 3. X to the 4th divided by x cubed is just x. And then negative 14 divided by 7 is negative 2. And x cubed divided by x cubed, again, is 1, so I don't have to worry about it. So I get 7x cubed times x squared plus 3x minus 2. I mean, that's the gist of it. Of course, it will go a lot faster and be a lot easier if you know a lot of your multiples. If you're able to recognize when something is a multiple of 2 or multiple of 3 or 5 or 6 or something like that, that will be very, very helpful. It's usually the number part that people have the biggest issue with, not the variable part. Variable part's pretty easy. So thanks for playing, and I'll catch you on the flip side. Laters.